Hello, and welcome to another video on the NextSciPaper channel. I hope you have been able to extract practical insights from our previous sessions. Without further ado, let's dive into new topics. In this seventh part of our introductory article reading series, we are going to explore bibliographic databases. We touched upon this briefly in previous sessions. We mentioned that there are platforms where you can extract your scientific articles and documents. Their primary task is to provide you with access to articles, allowing you to easily browse a vast collection of papers across various journals. There are many bibliographic databases. Each discipline might have its own specific database, or they may be categorized differently. There are various types of these databases, and I want us to discuss them one by one. We have mentioned several such as Scopus, PubMed, Web of Science, and ScienceDirect. There are many different databases that we use according to our needs, and while each has its own differences, generally, the user interface of all these databases is similar. This is because there is a set of standards for how a database is created, and all of them must comply with these rules and possess those features. Therefore, almost all bibliographic databases look alike, provide identical tools, and behave according to a similar logic and algorithm. Before we enter their actual websites, let me provide an explanation. You see, there are two models of bibliographic databases. Imagine these two boxes here represent bibliographic databases. There is one group of databases that contains more limited articles, for example, ScienceDirect. ScienceDirect contains a limited number of articles, but why? Because a large group of journals that have been around for a long time, their journals and subgroups having grown significantly, created a database solely for their own journals. Consequently, you can only find articles from those specific journals within that database. However, there is another category of databases, and the very function of a bibliographic database is to display all articles from various journals to you. Perhaps this is the true definition of a bibliographic database. There are some databases that do not care which journal an article belongs to. They display it for you wherever it may be. They essentially perform indexing. We have learned that there are two types of databases. One series are indexing databases, and the most important ones are like Scopus, PubMed, and Web of Science. The other series are publishing databases, meaning they simply publish, or display, the articles of their own journals. For instance, Elsevier. The Elsevier database became so large with its subgroups of journals and articles that it built a database to categorize them. In ScienceDirect, you cannot find an article other than one published in Elsevier journals. The same applies to Wiley and Springer. But, as mentioned, there are bibliographic databases that we call indexing databases, such as PubMed, Scopus, and Web of Science. Their job is indexing. They are not owned by the journals, and they do not own the journals themselves. The primary goal of this group is to index and display articles. So far, we have understood that there are publishing databases and indexing databases. They also have other differences. For instance, you have more advanced search environments in some databases. All databases, whether publishing or indexing, have an environment called search, which you can use to find the article you want. All of them have an advanced search feature. If you click on it, it provides you with more advanced tools, and we will be working extensively with this section later. Regardless of the database, you will see this advanced search section, which takes you to a new environment offering more specialized tools. Think of bibliographic databases as stores. When you enter an online store like Amazon, you want to reach a specific product, and the application or site provides you with tools like filtering and searching so you can reach what you want faster and narrow down your choices. Bibliographic databases work exactly like this. They present their articles, which are their contents, their products, to you in this manner through a consistent environment. We said that all of them have a search environment, and their advanced search contains tools. Indexing databases, such as PubMed, which are the main databases, provide us with more search tools compared to publishing databases. Publishing databases have more limited tools for searching, which we will explain in a few minutes. Another point is that indexing databases only show you the article and do not provide direct access, they provide access to the journal. So, you enter a database like Scopus, and when you click on an article, it transfers you to that journal, where you might be able to download it if it is accessible. It does not give you permission to download directly, it acts as an intermediary. However, a publisher database like Elsevier grants you that permission because the database belongs to the publisher itself. There are other differences that I do not want to talk about right now because they are quite advanced, such as the relationship between articles that you can only find in indexing databases, like the citation network, which we will become fully familiar with in future sessions, and searching based on metrics like the H-index or impact factor, which we explained in previous sessions. You cannot reach these in publishing databases like Springer or ScienceDirect. Bibliographic databases provide a much better relationship between articles, allowing us to analyze connections, which we will work on extensively in future parts. Now, let me enter the most important section, and this is truly a section that we will need until the end of the path. Whether it is this course, article reading, academic writing, proposal writing, or thesis writing, we will need this environment until the end. Contrary to what many people imagine, thinking that it is a completely simple search environment where you just enter a keyword and click search, that is not the case. Behind all search environments lies an infinitely complex algorithm. A mathematician named George Boole created an algorithm and a search logic that bibliographic databases are using. This system uses a highly complex algorithm. We call this search system used by bibliographic databases the Boolean search system, which has a series of codes that you must write here. Let me do a simple search first. For example, I search for brain and hit search. Let me search in other databases as well. For instance, here and here. When we search, you see it brings up a group of articles and displays them to us. Other bibliographic databases show us a group of articles in the same way. As you can see, next to each search section in all bibliographic databases, there is a filter environment where you can filter the search to gradually make it more limited. For instance, I can say, only show me articles published in the last 5 years, or, only show me material where the article type is review. I can click on the database to show me only review articles. We discussed what review and original articles are in previous sessions. These features exist exactly in all bibliographic databases, regardless of whether they are publishing or indexing. We can specify the date range. As I said, bibliographic databases are online stores. Online stores have filters. When you go to Amazon, you set filters, such as, only show me Samsung mobile phones, or, only show me black men's shoes. It is exactly the same here. For example, you say, only show me articles from this publisher, or only show me articles that are open access, articles published in open access journals that we can easily access for free, in simple terms. One of the differences we mentioned is exactly this. Indexing databases generally give you more filtering environments, meaning you can sort your content more thoroughly. For example, in a publishing database, you might be able to sort by article type, publication year, and author. In an indexing database, you can sort by year, institution, language, topic, and many more. You can narrow down your choices and reach exactly the content you want, which is a very positive feature. That is why a database like Scopus is so practical and high level. We were talking about the search environment, and I explained the filter section so we wouldn't have to return to it. A simple search brings up some content, or we filter after searching. But we want to talk about advanced search. We said that the system used in advanced search is the Boolean algorithm, created by the mathematician George Boole. This system has set a series of rules for searching, saying, use these rules in the items I tell you so I can understand exactly what you are looking for. Let me take all of this to the advanced section. It says you have to make me understand exactly what you are looking for with a series of words. For example, if I want to search for physical activity or cancer, I might have several other keywords. My first keyword might be physical activity, my second, cancer, and my third, nutrition, and so on. I want to search these one by one and see how it works. For example, I want to search about sports and I have two keywords, sport and brain. I must first write brain, then write and, leave a space, and after that write sport. If I click on search, it will bring up every document that simultaneously contains both brain and sport. This is one of the tools of the Boolean search system. When you use an, it means it searches for the two factors before and after it simultaneously in scientific documents. The next tool is OR, which is used when you want to search and say, let this word be there, or that word. You say, go and bring me articles that either have the word brain or the word sport. You come to the search environment, and you see if I put OR instead of an and hit search, it does exactly that for me. It searches and finds which of the articles have either one or the other, it doesn't matter. Even if one of them is missing, it's fine, as long as at least one of them is there. So, if I want both simultaneously, I use an. If I want either one, I use OR. The next item is not, which is used when we want certain keywords to be excluded from our studies. For example, I want to search for studies on brain and sport, but I want to make sure the word muscle does not exist. I want it to go and find any article that contains both sport and brain, but absolutely not the word muscle. If it is present, delete it. That is, if it had brain and sport, but also had muscle, delete it. We search, and see the articles become more filtered. So now we understand and, OR, and also not, the three main tools we needed to master so far. There are three other tools in the Boolean system that I will explain here. When searching, you can use the double quotation mark. For example, I want to write a sentence and have that sentence searched exactly. For example, I want to write exercise is a factor for health, and I want this phrase exercise is a factor for health to be found exactly in any article where it exists. So we use this, we put a double quotation mark on this side and a double quotation mark on that side. This is a sign that is also used in programming. The next item is the wildcard. Its application is to find the word family. For example, if I have written education here, and I put a wildcard instead of the rest of the word, it goes and searches for every word that is in the same family as this, which is very practical, and we will talk about it and use it in future sessions. But let me add a fun fact. Why do we call it a wildcard? If you have watched poker games, you see that there is a card called the Joker, which is called a wildcard, meaning a card you can use in place of any other card. This word was borrowed from there. The last group is the parentheses group. This means you can use these parentheses to categorize. For example, imagine I don't just have one and or one OR, but I want to line up a series of queries. So I can use these parentheses to categorize and write longer queries so they don't get mixed up for a student who is just starting to enter studies. Maybe these three tools are not very practical and they don't use them much, but working with these 6 tools in combination will help you easily reach the article you want. Now, let's experience a practical process in the advanced environment to see how these Boolean operators help us in practice. We use the PubMed database, which is a free and powerful database in the field of life sciences and medicine, as the basis of our work and enter its advanced search section. Imagine you want to write a long and specialized search formula. We choose the word brain as the core of the subject. But we don't want a normal search, we want to create logical prioritization using parentheses. This command tells the search engine to find all scientific documents where the word brain must exist, and alongside it, either the word exercise or the word nutrition, or both, have been used. Now, we want to go one step further and use the not operator. At the end of the formula, we add the expression not blood. Our final formula looks like this. By doing this, the system finds all articles that combine the brain with exercise or nutrition, but if the word blood is used in an article, it completely removes it from our results. When we execute this query in the system, it displays the relevant results for us. After running the query, it is time to use the filtering tools that are located on the side of the page. Bibliographic databases are like a big online store where filters help you reach exactly your desired product. By setting the time limit to recent years, it displays more articles for us, but if, for example, you set the filter to a shorter period, it displays fewer articles for us. Also, by activating the full text option, the system filters out all articles where the full text is available and they are free. The next filter is the article type. Articles are divided into two general categories, research and review, each of which has a large number of subcategories. In the filter menu, you can specify that, for example, only systematic review articles, which have the highest level of validity in review studies, are shown to you. When you reach an optimal volume of articles by filtering and writing a query, you cannot open and read each one individually on the site. You must extract this information. This is where the CSV output capability comes into play. In different databases, this button might be labeled as Save or Export. When you set the output format to all results and the format to CSV, the system analyzes and downloads all the information, titles, abstracts, and specifications of these articles in the form of a light text file that opens directly in Excel. One of the main differences between indexing databases like PubMed and Scopus and publisher databases like ScienceDirect is in this power and breadth of output. A professional researcher uses this Excel file as their personal database. The technique is to open the downloaded Excel file and review the titles one by one. If an article is completely suitable for your proposal or thesis, make its row green. If an article is irrelevant, make it red so it is deleted, and if an article needs more investigation, make it yellow. Finally, with a simple shortcut key, Ctrl+T, turn the whole page into a table, and with color filtering, keep only the green articles. This makes your literature review process 10 times faster. Another key tool that exists in all databases, whether indexing or publisher, is the sort by option. You can classify your search results on two bases, either based on time, which shows you the most recently published articles at the top of the list, or based on relevance, where the system uses a mathematical algorithm to show you articles that have the most similarity and keyword repetition in the main fields first. In the advanced search section, you can even tell the system to look for your desired word in which part of the article. As you know, the standard global structure of articles follows the IMRAD model: introduction, methods, results, and discussion, and has different parts. You can change the search field in the advanced search drop-down menu. If you set it to all fields, it searches the entire text, which brings up very many results. If you set it to title, the system only brings articles where that word was used exactly in the title. The optimal and standard state is setting it to the title abstract option. That is, the word should be either in the title or the abstract so that if it wasn't in the title but was in other places and was useless to us, it doesn't waste our time. Ultimately, the main professional trick is to know that filters are not just buttons to limit results. There should be a research philosophy and goal behind choosing each filter. If your goal is to write a review article, since the goal of a review article is education based on valid data, you must go for the filter of articles that have higher citations or the level of quotes so that the credibility of your work is maintained. But if your goal is to find research competitors or scientific collaborators in the world, or you want to find a new subject for a thesis, you must set the filters based on time to see who is working on this subject today. Setting these tools correctly helps you avoid drowning in millions of articles and go directly to the 50 or 100 golden and purposeful articles that are worth reading. In the next session, we will implement all these techniques empirically on subscription databases like Scopus, Web of Science, and publisher databases like Springer, so that your mastery of scientific resource management is complete. Good luck, and I will see you in the next session.